Hey everyone, today we're diving into the world of sequences, special number patterns in math that follow rules. We'll break it down using fun examples like pizza, cookies, and even magical donuts. Let's go. Arithmetic sequences, a number pattern that keeps adding the same number every time. Imagine you get 2 slices of pizza on day 1. Every day after that, your parents give you 3 more slices. Your pizza stash grows like this: 2, 5, 8, 11, 14. Each day, the number goes up by the same amount. Keyword is arithmetic. You add the same thing every time. To find any term in the sequence, use this. The nth term is equal to the first term plus the number n minus 1 times d. Nth term is a term we want, n is a position, and d is a number you keep adding. Here's an example. We earned 10 coins for our first quest, and every quest after that gives 4 more coins. How many coins do we have after 5 quests? So, a of phi, we're trying to find a of phi, and we have a of 1 is 10, and n is phi. So we plug it in. A of phi equal to 10 plus phi minus 1 times 4, because we get 4 more coins every quest. So a of phi equal to 10 plus 4 times 4, which is 16. So 10 plus 16 is 26. After 5 quests, we have 26 coins. Geometric sequences. A number pattern where the numbers multiply each time instead of adding. They grow fast. Imagine you bake cookies. Every hour, we double what we had before. We're multiplying by 2 each time. So this keep multiplying pattern is a geometric sequence. So a of n equal to a of 1 times r to the power of n minus 1. A of n is the term we want. A of 1 is the first number. R is the number we're multiplying each time. We could call it a ratio. Or n, and n is the position. Here. We invest $3 and it triples every month. The sequence would look like 3, 9, 27, 81, etc. How much is our investment in 5 months? So we're trying to find the 5th term here after 81. So a of phi equal to a of 1 times r of n minus 1. R is 3 because we're tripling every month. N is 5 because we're trying to find the 5th term. And a of 1 is 3 because that's the initial investment. So a of phi is 3 times 81, which is $243. So after 5 months, we have $243. Recursive and explicit formulas. Recursive. Here, we're building the sequence step by step. Each term depends on the one before it, so we must be told the starting number. So here, we start with 2 cookies, and we get 3 more cookies each day. So day 1 is 2 cookies. Day 2, we have 5 cookies. Day 3, we have 8 cookies. So the recursive formula would be a of 1 equal to 2, so we know that. And then, so a of n is equal to a of n minus 1 plus 3. So today's cookies are just 3 added to the yesterday's cookies. So the generic recursive formula for arithmetic sequence is where a of 1 is the first term, a of n is the term we want, a of n minus 1 is the term before it, and d is a common difference. Then the formula would be a of n equal to a of n minus 1 plus d. Example 2. We have 1 donut. Every day, the donut count triples. A of 1 equal to 1. We know that. And a of 2 would just be a of 1 times 3, which is 3. And a of 3 would be a of 2 times 3, which is 9. And a of 4 would be a of 3 times 3, which is 27. So recursive formula for this would be a of 1 equal, well, we know a of 1 equal to 1. So it would be a of n equal to a of n minus 1 times 3. The generic recursive formula for a geometric sequence is a of n is equal to a of n minus 1 times d, where d is our common ratio, a of n minus 1 is a term before the term we want, and a of 1 is a starting number. Here's an explicit formula. This lets us find any term directly by using the position number. So for an arithmetic sequence, a of n equal to a of 1 plus n minus 1 times d. We're directly using the position number. Here's geometric sequence. A of n equal to a of n minus 1 times d. We're using the n minus 1 to find that term. Here's an example. We earn 4 points on day 1, and we get 2 more points each day. This is an arithmetic sequence because we have 4 points here, and we have 6, then 8, 10, 12, so on. The explicit formula would be a of n equal to a of 1 plus n minus 1 times d. D is a common difference, which is 2, and a of 1 is 4, and n is the position we're trying to find. So a of 5, since we're trying to find the fifth position, then it would be 4, which is a of 1, plus n minus 1 times d, so it's 5 minus 1 times d, so 4 plus 4 times 2 is 4 plus 8, which is 12. So the fifth term of this sequence, or like how many points we have on the fifth day, is 12. Here's another one. We start with $5. Every week our money doubles. This is a geometric sequence. 5 to 10 to 20 to 40 to 80. The explicit formula would be a of n equal to a of 1 times r to the power of n minus 1. a of 1 is 5. R equal to 2, because our money doubles. So a of n is equal to 5 times 2 to the power of n minus 1. We're finding the sixth term, which is the dollars after 6 weeks. So it would be a of 6 equal to 5 times 2 to the power of 6 minus 1. So it's 5 times 64, which is 320. And that's it. So let's do a recap. Arithmetic is equal to adding the same number. Geometric is multiplying by the same number. Recursive is where we build it step by step. And explicit is to jump to any number in the list. Now that you know how to read, write, and work with all kinds of sequences, see you next time. And don't forget to save some pizza and donuts for later.